All right, good morning, everyone. I'm trying a different room in my house today to see if I have less problems with the internet. The internet must have gone down literally between 50 and 100 times yesterday. Um, you should have gotten an email yesterday afternoon regarding me redoing the Chapter 4 test for you online. That was a private video. Then afterwards, I created a 3-hour long video from 9 o'clock until noon, which for some reason didn't record at all. So I went back and I re-recorded it. It was now 2 hours instead of 3. But I recorded that yesterday and gave you the associated URL, of course, and I gave you the associated GitHub repo as well. So the plan today is for us to go over chapter 12 of the Murach text. Tomorrow, we're going to take a look at the homework and lab problems for chapter 12. We'll talk about those at the end of class today. On Thursday, I will distribute by 7 a.m. the chapter 12 pretest. I will go over the pretest instructions between 8 and 8:15 a.m. You will then have 2 hours to work on it from 8:15 a.m. till 10:15 a.m. And at that time, I'll go over the test with you. All right. Now, I sent all of you an email last night, actually 2 emails. The first email that I sent you, I have graded everyone's hot number 4 test, and I sent you your copy of the test, and if you had points taken off, why those points were taken off. All right. The second email I sent you was to let you know that I have now graded everything that everyone had as of last night at 8 o'clock on their GitHub repos. All right. If for some reason you did not have an assignment in there, you got a 0 in the grade book, you can still do it and get most of the points. All right. If you don't turn it in too late and if the assignment is of high quality. All right. But again, your chapters 9 through 11 tests and homework were due last Wednesday. That's a week from a week ago. Tomorrow it'll be a week. Now, because people have asked, and I know I've said it before, but I'm going to say it again, there will be no class on Monday, July 3rd. There will be no class on Tuesday, July 4th, because of the fact that the 4th of July this year falls on a Tuesday. The president of Rankin Technical College, all right, Mr. Don Pohl, has decided that we will have off both Monday and Tuesday. All right. So when you come back on Wednesday of next week, that's when you'll take hot number 5, the chapter 12 hands-on test. So with that said, again, today the plan is to go over chapter 12 of the Murach text. I will tell you, and I know you hear me sound like a broken record and say this all the time, but it is imperative that you read the chapter. I'm trying to hit all of the high points with you. Do I miss some? I'm sure I do. Not on purpose. That's human nature. So again, the chapter presents the basics of creating and using classes in C# apps, including properties, methods, and constructors, static members, and the chapter ends with talking about structures, records, and record structs. I mentioned this yesterday. I'm going to say it again to you. There will the only time that you'll have to worry about structures, records, and record structs is when you are doing the the written test for chapter 12. There will be nothing in the homework, nothing in the labs, nothing in the pre-test, nothing in the hands-on test that will deal with structures, records, or record structs. All right. So it says when you complete this chapter, you'll start to see how creating your own classes can simplify the development of an app. The big point here is going to be code reuse. All right. And what we will get to by the time we finish this section is how we can create what's referred to as a class library, where we can take things that we do in a lot of different programs, put them into a class, put that class or have that class be part of a class library and bring it in to any program that needs it. All right. It says you'll, as a bonus, you'll also have a better understanding of how the .NET classes work. So we're going to start in just a moment with an introduction to classes. And again, much of this information you've already seen in the examples I've gone over with you. Then we're going to go into basic skills for creating a class. All right. From there, we'll look at the product maintenance application that they have, and I'll probably end up even bringing it up. All right. So in fact, I should probably do that right now. So give me a second here. And again, everything I'm doing, you have. Oops, let's do that there. And C# students, it's all the stuff you have. So let's see, student download, book apps, and this will be chapter 12. All right, so there is a product maintenance class and a product maintenance record that's done at the end. So let me grab that chapter 12 stuff and copy it out to the desktop. So eventually we'll take a look at it out there. All right. So an introduction to classes, basic skills for building or creating a class, the product maintenance app, more skills for creating and using classes. And the chapter again ends with a discussion of structures, records, and record structs. So let's get into it. All right. The idea is eventually you will be able to create your own classes. All right, which really can simplify the entire design process. While we do this, we'll also talk about some of the built-in .NET classes. So the first thing that's discussed here, and we'll look at the picture in just a second, is how to create a multi-layered architecture. And as it says, what you're doing, for lack of better words, with a multi-layered architecture is you are taking whatever it is you're trying to do and, for lack of better words, kind of breaking it up into different parts. Now, the first one that they're going to show in here is this 3-layered type of an architecture. And if we look at this, this is what they have. Now, do I expect this to totally make sense to you? No. All right. But quite often when you're given an application to do, you'll break it up like this. This is not the only way to break it up. But you'll notice you have a presentation layer, what's called a middle layer, and what's called a database layer. All right. In the presentation layer, that's basically how your program communicates with the outside world. All right, so it's the view, so to speak. It's what the end users can see. The middle layer, when they talk about business classes, those are kind of the rules, all right, that any kind of an organization operates under. For instance, if your goal at Rankin Technical College is to get a degree in AWD, you have to sign up for the program. And let's assume, to keep it easy, that when you sign up for the online version of the class, or um, the online class. Okay, so you do that. Okay, once you do that, what happens? Well, you sign up for the class, you pay your money. On the day the class is supposed to start, ideally at least, unless there's a problem, the class starts that day. All right, you're given the information such as the syllabus for the class. You'll be talked to about assignments, etc., etc. Now, if you went and looked up Jeff Scott, Rankin Technical College online, all right, then you wouldn't have, if you were somebody who had not signed up for the AWD program, you could still take a look at a lot of the lectures for this class because the majority of them I make public. But since you hadn't paid for the class, yeah, you might get something out of it. Yeah, you might learn some stuff, but you're not going to get a degree that way. All I'm trying to get across to you is with these business classes, they typically will help define the business rules of an organization. Now, when we get to chapter 18, but more in 19 through 22, we're going to be talking about databases. When we start to work with databases, you'll notice that presentation layer has classes, middle layer has classes, database layer has classes. All right. One of the things that we'll talk about more in your next class that most of you, or at least some of you will take, and that will be the AWD1111 and AWD1115. And those are the database-driven website development and database-driven website development 2 class. One of the things that we'll talk about in there, and I'm going to bring it up because it's similar to what we're talking about here, and that is it's an architecture that's actually referred to as, model, view, controller. All right, so it has 3 portions. It's got a model. And that's what we've referred to up here as a presentation layer. Okay. That's what the end user sees. Then we've got what's called a view. In fact, I was wrong. That's the view up here. So let me say that again. The view is the presentation layer that the user sees. All right. The model typically has in it either database classes and or business classes. Finally, you've got the controller. And that's kind of like the supervisor between the view and the model. So why am I bringing this up? It's not even the same thing because it's sort of an introduction into this. All right. So again, this presentation layer is like the view. This middle layer is like, basically, it's a combination. It's the model, both the middle layer and the database layer. All right. So the reason I'm bringing that up is not to confuse you, but notice in here what the author says. All right. A 3-layered application consists of a presentation layer, a middle layer, and a database layer. In practice, the middle layer is sometimes eliminated and its functions are split between the database layer and the presentation layer. That's not usually a good idea. And we'll get into the whys and wherefores in our later classes, but not in here. So the classes in the presentation layer, or what I can even call the view, handle the details of the app's user interface, also known as the UI. As it says, it typically in Windows Forms app, it'll be the forms that display the interface. One class will typically be required for each form we display in the app. The stuff in the database layer, and this is hard because we haven't talked about databases yet. All right. But as it says, it's responsible for all the database access required by the app. I'm not going to read that to you. They do mention on here, although we refer to this as the database, it can also contain classes that work with data stored in files. Then the middle layer is the interface between the two. All right. An advantage of doing this, and this is what the author mentions down here. One advantage of developing apps with this layered type of architecture is that it allows development to be spread among members in a development team. So in other words, if you're doing something that's very, very complex and you work with a company that has a lot of programmers, you could have one group of programmers that work on the user interface, all right, or the view type of layer. You can have another group that works on the database stuff, another group that works on the model stuff, etc. Another advantage, as it says, is once you do this and you create something more like one of these class libraries that we will be building toward, all right, in chapter 16, you'll be able to share these classes. Why? Let me try to give you a real life example. All right, let's pretend, we're just going to pretend here, but let's pretend that the people from, Enterprise Rent-A-Car decided that they wanted to build a whole new reservation system. All right. And let's suppose they came to Rankin Technical College and explained to us exactly what they wanted. And it became a competition. And I had all of you in my class kind of have a little friendly competition with all the people in Evan's class. All right. So we'd have this friendly competition and we'd each build our own reservation system for Enterprise. Well, let's say that now we're done and they pick ours, okay? And they're using it and they're very happy with it. Now, a couple months go by, and now let's say that I don't know, the Hyatt hotels, they go and contact me and they say, hey, you know what? We want to redo our reservation system, and it's not really that much different than the reservation system for Enterprise Rent-A-Car. Yes, we're renting rooms instead of cars, but the process is the same. Well, by doing some tweaking, we'd probably be able to take what we had originally, make changes, updates, etc., and now make it work. Instead of having it work for cars, having it work for hotels. And again, we'll talk more about this as we go on. So again, this is the architecture. I don't want to sit and read this stuff to you. All right, I'll leave it up there for a second. Okay. Not every application is built using a 3-layered architecture. It's actually possible to have more or less layers. The one thing I don't like that they say in here is they talk about sometimes you don't even have this middle thing. Rather, you take some of this and you give it to the presentation layer and some of this and you give it to the database layer. That's not usually a good idea. This is going to be basically the client side, and this is basically going to be the server side. The more power you give to the client, the fatter, so to speak, the client becomes, and the thinner the server becomes. The more power you give to the server, the fatter the server becomes, and the thinner the client becomes. All right. I've always been taught that you should try to have a thin client when possible. Okay. So we've already looked at a lot of this stuff, but let's talk about it again. All right. It says the members of a class include its properties, methods, and events. So far, we've concentrated on the properties and the methods. All right. In addition, we've also concentrated on what? Like the instance variables. Throughout this book, you've seen many examples of apps that work with .NET classes. You've used constructors. We've done that. For example, again, I go back to the random number class where we said like random rand equal new random. Okay. The classes you design yourself can also have properties, methods, constructors, and events. So the first one they're going to show in here is this product class. So the product class, when you look at the members right there, it's saying that each product will have these three pieces of information. A code, which is a string that uniquely identifies the product. A description, which is a string that describes the product. And a price, a decimal with the product price. Those are going to be the instance variables for each product that we create. In addition, we're going to have a get display text method that, as it says, will return a string for us where we concatenate together the product code followed by its description, followed by its price. And you'll notice that there is, for this get display text, there is also a parameter that's passed to it. It's called sep, and it's a separator. It's how you separate the code from the description from the price. It could be a tab. It could be a new line character. It could be a pipe character. It could be something else. Also notice in there, we have a constructor. Now notice that the constructor is going to be empty. You saw this in the example we went through yesterday. And that is that when you've got an empty constructor, it's going to take code and set it equal to the empty string. It's going to take description and set it equal to the empty string. And it's going to take price and set it equal to 0.00 M. All right. So properties, as it says, are data values associated with an object. Methods are operations that can be performed on the object. And constructors are a special type of method that gets called when the object is created or instantiated. All right, before we look at this, which we're going to do, let's make sure we haven't missed anything in here. So it says below the second table is the complete code for the product class. As you can see, it begins with a class statement that declares it. It'll be a public class. All right, the public be put in there will mean that it will be possible for other classes to communicate with it. In other words, the class won't live on an island, so to speak. All right, so maybe we'll bounce back here, but let's look in here and let's actually see what we have. All right, this is assuming that we created a project and we named that project product maintenance. How do we know that? All right, how do we know that that's what we did? We know that because that's the name of the namespace. All right, and in this product maintenance namespace, we've gone in and we have created a new class. The name of that class will be product.cs. And you'll notice where it says a constructor, and right now it's got just empty parentheses in it and empty curly braces, which means it's the default constructor, which means it'll look for our instance variables or properties in this case, which will be code, description, and price. And it will set code equal to the empty string. It will set description equal to the empty string, and it will set price equal to 0.00 M. Now, they showed in here defaulting the strings, but you don't really even have to do that. I don't think I've ever done what they're showing right there, but you can. All right. Then after these three properties that we've set, notice we haven't set instance variables directly. All right. Instead, we're using the property auto-implemented properties that we talked about yesterday. Okay. And in addition to that, we have a method at the bottom. That method is public. All right. That method returns a string. And when you look at it, it has a separator that's passed in, and it will show the value of our code, followed by our separator, followed by the value of our price, followed by a separator, followed by the description. Okay, so this should all be reviewed to you in here, everything that you see on the bottom. All right, an object is an instance of a class. An object contains typically properties, which can be set up as properties, auto-implemented properties, or instance variables with our own get sets. It contains methods, all right, which again could be get set methods and or could be other kinds of methods. And anything else we need. So the class, again, is the blueprint that defines what the objects are going to look like. An object, again, as they mentioned, is an instance of a class. The process of creating an object from a class is called instancing or instantiation. So an object is an instance of a class. In addition, we talked about encapsulation. As it says, it's one of the fundamental concepts of object-oriented programming, or OOP. And what encapsulation does is it gives you control over who can see and do what with your classes. The data is typically encapsulated or hidden using data hiding. In addition, as it says, the code that performs operations is encapsulated so it can be changed. I mentioned two terms to you the other day, those terms being interface and encapsulation. And I even used an example like this, where if we come out here and I bring up the calculator, that's my interface. So if I want the square root of 367, I type in that and I click one of these buttons. All right. But to be honest with you, I don't know how that's been implemented. I do not know what happens internally inside of this piece of software where when I put that in, put in 367, and then hit that key, I don't know how it magically converts this, and I don't care. The implementation or the inner workings have been hidden from me. I only have to know how to use the interface. And again, the advantage of that is if the implementation if the internal interworkings change to try to make it better, but my interface does not change, I'm none the wiser, as they say. All right. So let's jump back here, make sure we didn't miss anything. Says, notice that all of these members use the public access method modifier to identify properties and methods. By contrast, you use the private to declare members that you don't want to be accessed by other code. So what we're going to talk about in here are in a little bit are these different modifiers. There are really about 6, out of which probably 99% of the time, there are 3 of those 6 that you'll use. All right, and they talk some more about encapsulation in here. I think we've kind of talked about that enough. All right, so you've got this class. How do you create objects from the class? And there are plenty of ways of doing it. All right, what do I mean? Well, let's suppose going back to the example that we did yesterday, the baseball player examples. All right, you saw how we went in and manually created a Murach baseball player object We manually created an Albert Pujols baseball player object, and we manually created a Stan Musial baseball player object. That's fine when the number of objects that you have to work with is limited, when you don't have that many objects that you're creating. However, imagine that I wanted to do that for each, and I think that the rosters on major league teams, there's something like 26 players. I think that's what they are. All right. And in addition, there are 32 teams. So 32 times 26 be around 812. I don't know, 832. I wouldn't want to sit there and have to manually create 832 baseball player objects. All right. I could probably come in and create an array and then grab that information. Maybe somebody else, maybe some data entry person had put that information into a file or filed someplace. Well, that would be much easier than for me to work with. All right. So we're going to talk about all that as we go through here. So again, as mentioned, the process of creating an object from a class is called instantiation. So they're going to show in here how this works. And again, there's different ways that you can do it. Most of the time that we've looked at in here, it's been this: the name of the class, followed by the name of the class variable or the object, equals new, followed by the name of the class. And you'll notice that that says that that is explicitly typed. When something is done explicitly, you do it. All right. It's something you do, which means you have total control over it. On the other hand, when you look at the second example that's in there, notice it says var. Var followed by the name equals new class name. Then after that, it says implicitly typed. What that means is you are giving some of the control over to the computer. So when something is explicit, you're in charge. When something is implicit, the software is in charge. In addition, there's another way that you can do it that they show up here. The name of the class followed by the variable name equal new. One thing hopefully you can notice when you look at these is one thing that happens every time that we've gone on here from explicit to implicit to C#9 or later is the syntax has gotten more simplistic. There is less typing that you have to do each time. All right. So we're going to look at all three of these. All right. So it says the first syntax, the first one we looked at, the second one, the third one. So I'm not going to go through those. It says next we make two instances of the product class. All right, so what are these? These are product objects. The first one is using this product one equal new product. So it's using the explicit way of doing this. The second one says product two equal new. It's using the third way of doing this. It's not, again, it's not important really which one you use. What's important is that you do understand what's being done here. All right. When we do this line, whether it's this line right here, product one equal new product, or it's this line right here. In both those cases, we are creating a brand new but empty product. How do I know that in both cases it's empty? Because after the word product here and after the word new here, the parentheses are empty, which means that until you come in and fill in the code and the description and the price. That means the code is set to the empty string, the description is set to the empty string, and the price is set to 0.00 M. All right. So the line that declares the object is right there and right there. Then we initialize, and you'll notice that we initialize these objects regardless of the way we create them, we initialize them in the same way. The name of the object dot, the name of the particular variable, all right, equals, and then something. So these two look exactly the same. All right. That's not terrible. You know, it's 4 lines. It's 4 lines. And also notice there's another way you can do it. This is called an object initializer. And when you do this, you'll notice you don't have to say product one dot code, product one dot description, and product one dot price. You only say code, description, and price because it's inside of, it is inside of curly braces. Notice there is a semicolon here, 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 and here. There is a semicolon here, 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 and here. But doing it this way, there's only one semicolon, it's at the end. But you do put a comma in between each one of the members except the last member. This, in many ways, looks like when you set up an array and you give it a value at the start. All right. So again, when an object is instantiated or created, a constructor is automatically executed to initialize the data that makes up the objects. If the class doesn't provide a constructor, the default one is executed, which sets everything to default values. We talked about this yesterday. Strings automatically become the empty string. Numbers become 0 or 0.00 or 0.00 M, etc. All right. Booleans become false. Dates become, I think I never, but we'll see it in a little bit, but I believe it's like January 1st of the year 1 at midnight or something like that. All right, let's jump back because I don't want to skip anything that's in the chapter. Now it says the use of object initializers improves your code by making it more concise. Some people look at that and find that it's a little bit more confusing to use object initializers. If you're one of those people, don't use them. All right. Then just do it one of the other ways. And the final paragraph on this page that you see here on 378 says at this point, it's important to realize that a class defines a reference type. What does that mean? That means that if you go into the computer memory and you find where that class is being defined, you won't find those members in there. Instead, you'll find an address, and that address refers to where else in memory all that stuff is defined. So it doesn't have the actual value itself there. It has a reference to that value, not the value itself. All right. Let's see. This is an important point here, this second bullet. The data that makes up an object is sometimes referred to as the object's state. So the state of the product one object is its code is C#, its description is Murach C#, and its price is $59.50. Well, why is that important? You want to make sure that the object, even when it's first created, and you use an empty or default constructor, that the state is put into something where it won't break. Now notice the third bullet. The state of an object changes whenever you change the value of one of the object's properties. The state can also change when you call a method that affects the data in the object. An app can create 2 or more instances of the same class, as many as it needs. Each instance is a separate entity with its own state. I used human beings. Another one you could look at would be cars, as an example. All right. I can have a car. Another person can have a car that looks exactly like mine and has the same characteristics, but they're going to be different. If for no other reason, the VIN number, the vehicle identification number, will be different between the two of them. All right. If you change the state of one object, it doesn't affect the other objects. All right. Object initializers, then, as it says, let you create an object and assign values to that object in one statement. This is one statement, and because there's only one semicolon and it goes at the end. Finally, again, as we already mentioned, the class defines a reference type. All right. So it contains the address of the object and not the actual object itself. All right. It says now that you've learned a little bit about the members that make up the class and you've seen the code for the product class, now we will talk about some skills for creating and using your own classes. Okay. To create a user-defined class, and you've seen this already, you start by adding a class file to your project. Nothing new there. So, and that's the one thing, and I don't know if I ever mentioned this or not, it is very, very, very important. A class file is a .cs file that has no user interface in it. I want to say that again. A class file that you create or that you use has code in it, but no user interface in it. Not saying it can't manipulate a user interface, but it has no UI in it itself. So a class file is all code. When you add a class to a project, Visual Studio automatically generates the class declaration. Then you can go in and add whatever you need, as they mentioned, your own constructors, your own properties, your own methods, and whatever else you might need. By default, it generates an access modifier of internal. We're going to talk about that as it says in the next chapter. We're going to change ours from internal to public every time we create a class, meaning that that particular class will be accessible by any other part of the project. As it says here, Visual Studio also generates some using directives by default. You can leave them in there, or you can delete any ones that are gray that you don't need. It doesn't matter. So you've seen this already. Again, this is the kind of thing that you come in and you right mouse click on your project name, you choose add, and either in this case, we would choose new item and then we would choose class from here. But remember, you can also right mouse click, choose add, and down near the bottom it says class. Either one of those ways will work. All right, these are typically the things that you're going to get in here. Some of these we've already worked with. The using system is kind of a given that you just need it for, a lot of things that you do. The collections.generic is typically means that that's there if you want to use lists or dictionaries, etc. The link we'll get to in chapter 18. The text will allow you to do different things with text. And if you want to be able to do more than one thing at a time, you might use the threading. But quite often, if you're doing something, the more simplistic you're doing something, the better the chance that you might keep system and get rid of all the rest of these. So when you complete the add new item dialog, a class file is added to the project. Whatever name you gave it, .cs. The namespace is added automatically, and it'll also say internal, as it says right here. Virtually always, one of the first things we're going to do is to double click on this word internal and type over it or change it or remove it, but we'll put public there. The namespace and class blocks, as they're shown right here, the class is part of that namespace. You can have more than one class that's part of the same namespace. All right. By default, the class block that Visual Studio generates has an access modifier of internal, which, as it says, is similar to private. You'll typically want to change this again to public. And I know I'm doing this almost unbelievably slowly, and I want to make sure that people understand what we are doing. All right. So the next figure that's in here that we'll look at momentarily. All right. As it says, that particular figure is the syntax for creating a property. Okay. So we're going to do that right now. It says the property declaration specifies both the type and the name of the property. In addition, it's typically declared with a public access modifier so it can be accessed by other code. All right. There are several examples in here. We've done some of these before. All right. Or basically most of them. All right. And we've seen that there's different ways of writing the same thing. So for instance, we can do this, which means, we can set up something like this. If you remember from yesterday, this was one of those auto implemented properties. All right. What this says right here is anytime we come in, assuming that this is part of the product class, if we say product.code equals this, it's going to call the setter. If the product code is on the right-hand side of the equal sign and we're copying it into a variable, we're using a getter. All right. If you have a get without a set, it's read-only. So for instance, they've set this code up to be C#, so you can't change that. It is also possible, even though they don't show it in here, that you can have a set without a get and have a write-only property. That's done much less often than read-only, but you can do it. So as they mention here, accessors provide access to property values. They're also known as getters. All right. Setters or set accessors, all right, are also known as mutators. If you've got both a getter and a setter, then the property is a read-write property. If you have a getter without a setter, it's a read-only property. If you have a setter without a getter, it's a write-only property. But as they say in here, that's very rarely done. So they give some examples. And as it says here, the first example shows a read-write property named code. It says here, although not shown here, it's considered a good practice to assign an initial value with a type that can possibly be null. All right, they show that here. So you can do that. All right. And if you think there's a good chance at least that, wow, it's null. Why do you care whether or not it's null? Because if you try to print it out before you've given it a value, you'll get some kind of a null reference exception, which you don't want to have. All right. And they give you more examples. And they say the fourth example uses an assignment statement. The fifth uses what's called an expression bodied property. And they talk about a lambda operator. All right. And then it says again, with C# 9.0 and later, you can use the word init. All right. Part of the problem is this is so popular and so strong because you're given several different ways of doing the same thing. Now, to some people, that's a blessing. To some people, that's a curse. We're going to look at those in just a second. But down towards the bottom of the page, they talk about those auto-implemented properties. All right. And that's what we used yesterday with just the get and the set. So when we look at these examples that are right here, we've got 1, 2, 3, 4, 5, 6, 7 examples. This is just the syntax. So this is one of those auto-implemented properties. We've set it up and it's got get set. All right. Next, we show that when you actually do a setter, so when the name of the property is on the left-hand side of an equal sign, how that's done. Then we show a getter when the name of the property is on the right-hand side of an equal sign. Then you're shown how to do a read-only property with just a get. Since the write-only is done very infrequently, that's not even shown here. Then we've got, so notice they're shown two different ways of setting the same read-only property. All right. Now you might say, well, I'm going to use this one. It's less typing. Then use that one. That's totally fine. But to some people, doing some of this stuff can be very confusing. In an ideal world, what you will do is you will look at this, you will see what makes the most sense to you, and you use it that way. All right. I don't think I've ever done this, the property with an init only, or this. I don't think I've ever done either one of those. All right. Mainly because I've been doing it for a while and I'm very comfortable doing it with the ways that they showed previously. So you use a property to get and set data values. All right. You code a get accessor or getter to retrieve a value. You code a set accessor or a setter to set a value. Get accessors are also known as just accessors. Set accessors are also known as mutators. A property with both a getter and a setter is called a read-write property. A property with just a getter is a read-only property. A property with just a setter is a write-only property. And again, write-only properties are used very infrequently. You can also use an expression body to code a read-only property, as we saw. You code the access modifier, the return type, and the property name followed by the lambda operator, which is an equal sign followed immediately by a greater than sign. The lambda operator is going to be discussed, especially when we get to around chapter 19 in a lot of detail. You can initialize the value of a property by coding an equal sign, the value, and a semicolon following the closing brace for the property. Again, these are all the newer things. Now, on the very bottom bullet here, it says the properties shown are auto-implemented properties. All right, which means that when you put them in the way they're shown, you're not able to change them on those lines. You've got to change them in other parts of your code. All right. Methods are the behaviors of the class. It's what you want the class to be able to do. So for instance, if I had a person class, and we went over this last week, I believe, if I had a person class, I might say that any person is able to eat and drink and sleep. Those would be three methods, all right, that would be associated with a person class. It says, because the basics of coding methods were presented in chapter 6, most of the information in here is review. The main difference is that the methods presented here use the public access modifier. Virtually all the time, when you create a method, you will make the method public. It's not mandatory that you do that. Typically, if you make a method private, it's called a helper method. So for instance, if a public method has to call another method to do something, you might make that private. And I've given this example before. Maybe it's not a great example, but I'm going to use it anyway. All right. So let's suppose that I'm lecturing like this. And when I do, my wife was nice enough to put one of my waters off to the side. So if I get thirsty, of course, I can drink it. But what if I ran out of my water and I just kind of looked at her and I was like, hey, go get me a water, please. And she thought, okay. And then she noticed my daughter was already in the kitchen. So she called out to my daughter, had her get the water, gave the water to my wife, who gave it to me. All right. Well, the act of having my daughter do something would basically be private. I wouldn't have to know myself that my wife went in and called my daughter to do some of the work for her. It doesn't matter. All right, so that would be private. That's not the greatest example, but hopefully it makes at least a little sense to you. All right. The example they're going to use in here for a method is that get display text. As it says, it uses a return statement which returns a string that appends together all three of the values. Now they're going to show you other ways of writing it in here. So you'll notice we could do it like this. All right, and in the curly braces, or if you don't want to, this is just a shortcut. Since this is one line of code here, we can remove the curly braces and the word return and replace those with the lambda operator. So these two expressions are doing the same exact thing. They're both a method that accepts a parameter. In the first example that you see there, that's more the older, tried and true way of doing something. In the second example that you see there, that's the newer fangled way of doing it using an expression body. They both work the same way. It says expression bodied methods don't provide as much simplification of code as expression bodied properties do, even though you should consider using them for consistency. I'm not going to agree or disagree with that, but what I am going to say is if you're given 1, 2, 3, 4, 5, 6 ways of doing the same thing, look at all of them and see which way or which ways make the most sense to you and use them. I'd rather, if you're given 4 ways of doing something and one of them, that makes total sense to me. The other ones, then use the one that makes sense to you all the time. That's totally fine with me. All right. It says in chapter 13, you'll learn how to use lambda operator to code expression bodied indexers and operators, known as lambda expressions. Those are frequently going to be used with LINQ, and that's what we discuss in chapter 18. All right. So I don't think we have to read any more in here. I'll leave it up there for a second, but we've already talked about this. Again, one of the drier lectures you're going to hear from me. All right, because I'm going through this slowly and trying to hit everything that's in here to make sure you understand what's going on. All right. Next are constructors. You already know this. A constructor is a special method that automatically gets called when a class is instantiated or when an object is created. If you do not create your own constructor, a default constructor is called, which will set any values you've got in your thing to their default values. You're going to see what those are in just a minute. So as they say here, by default, when you use the new keyword to create an instance of a class or an object, C# assigns default values. If that's not what you want, you can take your constructor and assign anything you want that's of the right type, etc., to any value that you have in there. So to create a constructor, as they mention right here, you declare a public method that has the same name as the class. That constructor cannot have a return type. All right. And again, must be public. Technically, it doesn't have to be public, but you're going to find 99.99% of the time it will be public. So it says here, the first example in this figure shows a constructor that doesn't provide for any parameters. So again, the first example that's in here is that default constructor. We've already talked about that. So if we have code, description, and price in there, code is now automatically the empty string because it's a string. Description is automatically the empty string because it's a string. And price is automatically 0.00M because it's a decimal. So here's one with no parameters. Sometimes it's called the default constructor. Sometimes it's called the no-arg, no-arg for no argument constructor. This right here has got all of them in there. So I sometimes call this in mine a full arg constructor. All right. Now this is an overloaded constructor. You can do that and have two constructors with the same name as long as what's in the parentheses is different. So in the first case, there's nothing in the parentheses. In the second case, there are three numbers, or three values, I should say, three arguments in the parentheses. And then they show you different ways that you can call these constructors. So the first two that they show here are going to call the empty constructor, or the default, or no arg, and the last two are going to call the constructor with three arguments. All right. If you code a constructor with parameters, the compiler will not automatically create a default constructor for you. Say that again. If you code your own constructor and that constructor contains one or more parameters, the compiler will not generate a default constructor with no parameters in it. So if you want one of those as well, you must create your own. All right. Now, they'll also show you a new couple of ways that you can create these. So let's look at those. So as it says, a constructor with an expression body. So this is another way you can do this. This is an expression body with a tuple. We didn't really talk much about tuples earlier in the semester. They were in one of the chapters. The bottom line is, if you look here, there's 1, 2, 3, 4 different ways of doing the same thing. But the one that you should use is the one that makes the most sense to you. When you use this default constructor, as we said, all numbers are 0. I was told once that actually for a decimal, like, or it's 0.00m, and for a double, it's 0.00, and any kind of int is just 0. Does it really matter? Not really. All right. Strings are the empty string. Booleans are false. A character would be null. An object is also null, and a date is midnight, January 1st of the year 1. So again, just to review, the name of the constructor must be the same name as the name of the class. It must be declared with a public access modifier. It must not have a return type. To code a constructor with parameters, code a data type and name for each parameter. If a constructor doesn't set a property and the property was not initialized when it was declared, it uses the defaults that you see in the table above. All right. Finally, in the later versions here of C#, there's other ways of doing this as well. An expression-bodied constructor using the lambda operator, or an expression-bodied constructor with a tuple. All right. Now, I may have mentioned this to you earlier. I don't remember if I did or not. Okay, but I'm going to show you something real quick here. It's not meant to impress you. It's not going to impress you. But I'm going to come in here and I've got this. All right. And now I'm going to come in here. I'm going to add a couple things. That's not what I want. All right. All right. Years ago, I taught a class at a different college, and the class was in Java, the Java programming language. Okay. So there's a point to me telling you this, if you just bear with me for a little bit. Okay. These were both buttons. This one said grow, and this one said shrink. All right. And this right here actually was colored in, but it doesn't matter. It's just a dot. It's just a dot. Every time you click this grow button, it got 10 pixels bigger. Every time you click this button, which was called shrink, it got 10 pixels smaller. All right. So what does this have to do with anything? All right. Well, after a while in here, it got to the point where this was actually meant to be a balloon, believe it or not. And it would be like when you click grow, it would be like you were breathing air into a balloon. And when you click shrink, you were taking air out of a balloon. All right. But as time went on, this wasn't enough. So what you started to do was you started to create other balloons. All right. So we made other ones. Again, what does this have to do with anything? Well, if one of the things that I wanted to do when I was creating balloons was to keep track of how many balloons in here I had, I could make a variable that was called balloon count. And ideally, it would be equal to 1 and 2 and 3 and 4. If I make another one, it would now be equal to 5 because there would be 5 balloons in here. All right. The problem is if I come in here, like we've got here, and we create another field in here that's an int that's called count, all right, That would mean that each product, for example, would have its own count. So if I had 10 products, I would have 10 product counters, each with a value of 1. But I don't want that. I want the opposite. I want one program counter with a value of 10. So in other words, I want to be able to create something once and have it be shared by all objects. Why am I telling you that? Because that's where static comes in. All right. There's two things about static variables, and they're both connected to one another. It says here, as figure 12H shows, static members are members that can be accessed without creating an object. You can just use them. For instance, if you remember earlier in the semester, we did something like this. We would say, random rand equal new random. All right. Whoops. And then we said int number equal rand dot next, and we'd say something like 101. And what was that doing? What was that doing? All right. The first thing this was doing was creating an object of the random number class called rand. Then what this is doing is it's calling one of the objects, I'm sorry, one of the methods from that random number class called next. All right. Well, that's all fine. Okay. But do you remember this? So this is a case where we are actually creating an instance of a class and then using that class's method or that object's method. All right. But we also did stuff like this. Maybe not in a lot of depth and breadth of coverage, but I could say like double value equal, and let's do this. We're going to say here int x equal 387. All right, now I'm going to say double value equal math dot sqrt of x. What's that going to do? That's going to give me the square root of 387. It'll be somewhere a little less than 20, 19 point something probably. I don't care what it is. The point is, in this case, I'm using the math class and I'm not creating a math object. When we did it ourselves, we had to create an object so we could go and use its methods. But with something like the math class, it's shared by all programs. You don't have to create it. So the math class is an example of something that's static. It's able to be shared and you can use its methods without having to create an instance in of the class. And there's other ones as well. So to create a static member, as it says right there, all you have to do is include the static keyword in the declaration. All right. So it says the static is present method validates the value passed to it to make sure it isn't an empty string. If it is an empty string, this assigns an error message to that message value, and then it returns that. Does that sound familiar? All right. We've done this kind of thing before. All right. Now, when you look in here, because this is one of the more complex examples that we've looked at in here thus far. All right. So we're creating our own class called validator. You can see that it has one instance variable called line end, and we are initializing that to \n, which is a carriage return. In addition, we have in here a method called isPresent that returns a string. All right. And we're able to start using it. So it's going to see if that, so it's got an empty message here, but if the value we're checking is empty, then it's going to fill up that to say the name of it is a required field. And the line end will just mean put a \n at the end. All right. So code that uses these static members. Now this is an example. There is a class here called validator. All right. We're using it directly with the name of the class. We are not creating a validator object. I want to say that again. We are not creating a validator object. We are just using the methods and variables provided by the validator class without having to create an object of that class. So as they say here on the bottom, a static member is a property or a method or something else that can be accessed without having to create an instance or object of the class. To define a static member, you use the static keyword. Since you don't have to create the object, this static member can be shared, all right, by any class that you make it available to. Static properties and methods can only refer to other static members or to variables declared within a property or method. These are just the business rules here. A constant that's declared with public is implicitly static. If you create an object from a class, you cannot refer to a static member through the variable for the object. You can refer to a static member only through the name of the class, so you don't instantiate it. All right, typically at least. If a class contains only static members, you can put the word static in front of the class. As it says here, by doing that, now you are not going to allow, or you're going to disallow, programmers from putting something non-static inside of the class. Finally, the bottom bullet there, the using static directive lets you refer to static members of a type without naming the type. So they put all that in there, and then this using at the top, putting that using statement in there like they show, would allow you to be able to use this. So you could create this in its own class and then bring this into other classes with that were in the same project. All right. So now it's time to go into this product maintenance app. So we are going to look at an actual application that uses this stuff. So as they mention here, the topics that follow present a product maintenance app that maintains a simple file of products. We have not talked about files yet. They are the subject of chapter 17. All right. This particular app will use 3 classes that we define. All right. 2 classes provided by the form and the program class that starts the app running the first form. We'll look at all those in just a bit. All right. So let's look at this and then we'll go back and look at it and then we're going to bring it up. It says the figure on the next page describes the operation of the product maintenance app. All right. It'll have 2 forms and a dialogue. The main form, as it says, will retrieve a list of existing products that are in a file, and it'll display those products in a list box. All right. The user can use this form to, if they highlight, if they click a button in there, they'll be able to add a product, or if they highlight an existing product and click delete, they'll be able to delete a product. so they can add a new product or delete an existing product. If they click the Add Product button, it's going to bring up a new product form, and it'll be modal. So then you can enter the data for the new product, click the Save button, and it'll basically, for lack of better words, it'll, as long as what you put in there was valid, it'll redraw the list box for you. If you put in something incorrect, so for instance, if it's asking for a number and you put in something non-numeric, you'll get an error message. After the product is saved, again, the list box is refreshed, so it'll include the new product. You can also cancel, so if you say you want to create a new product and then you change your mind, you can do that by clicking the cancel button. After the product, I'm sorry, to delete a product then, you select the product in the list box and click the delete product button. All right. So this is what it's going to look like. So when we bring it up and load it, it's going to bring up this main product maintenance form. It is going to go out to this file that's got that information in it, and it's going to basically put it on the screen in a list box. And it's going to have a separator in there, which is either going to be a blank space here or a tab. All right. So it's going to show you for each record the three components. This is product maintenance. So this is product code, product price, product description. You'll notice that the price has been formatted as a currency. If you click the Add Product button, it'll bring up a new modal form, which will expect you, if you click Save, that you have entered a string for the code, a string for the description, and a decimal for the price. If you've done all that and you click Save, it should redraw this or refresh this with your new product. So notice here, and we'll do exactly what they're doing. It should come up and show us this. And then we'll put in this, and when we click Save, it should now add this at the bottom. Then if we decided, oh, we made a mistake, or it's already in there, or whatever, we can highlight the file, click Delete, and it'll say, are you sure you want to delete that? And if we say yes, it's gone. So that's how this works. So as they mentioned here, the product maintenance app retrieves product information from a file, displays it in a list box, and lets the user add or delete products. To add a product, we just went through that. To delete a product rather, we just went through that. So they're going to go through here and talk about the classes. Before they do, let's go ahead and run this. So let's bring up, I brought it in here, it's in here someplace, it's CH12. This is right from your book. And it's the product maintenance class, so we want that one. So let's run it. Now, if we run this, I don't know why we're getting that, but there we go. There it is. We only have one book in there right now. All right. So if I click Add Product and I put a code in there, and let's put in Java. And the description will be Murach Java, let's say 7th edition, and we'll make the price $66.99. Now, if I click cancel, it's gone, nothing happens. If I click it again, and let's do it again, and we'll make this Java, Murach Java 7th edition, and we put in here $66.99. Now, if we click save, it's redrawn our list for us. All right. If we attempt to delete a product, but we don't have anything highlighted, it won't do anything. If we put this in and then click delete, it'll say, are you sure you want to delete Murach Java 7th edition. And if we say no, it leaves it there. And if we say yes, it's gone. All right. And exit pretty much works the way you'd expect it to work, except they use theirs, which is just going to close this. All right. So if we look in here, what do we have? Let's just look at everything that's in here. All right. So we've got this new product. It's a form. There it is. Let's look at the code. Start it right here. Private product equal null. What is that doing? All right. Basically, that's going to create a product for us, which could possibly have a problem with nulls. So we're allowing nulls by doing this. All right. We've got a get new product, which is just going to return a product. We've got our save. This is creating a new product right here. It's grabbing whatever we put into the text box for the code, and it's setting the product.code to that, the product.description to that, and the product.convert to decimal to that. Now, I didn't show you this, but what if we click add new product and I come in here and I say Java and I say Murach's Java 7th edition. Now I come in here and leave this blank. Well, notice it says price must be a valid decimal value. Okay, and if I come in here and just type in hello, again, product must be a valid decimal value. What if I come in here and make it negative $45, and I click save? It took it. So there's no check for that. All right. And notice there's no update in here. So if I did that, oh, I made that negative. I didn't mean to do that. I'd have to remove it and then add it back in again. All right. But you'll notice in here, we've got that is valid data. And now it's not in here. Is present is not in here. No, because it's now in its own class. We have taken this and created a validator class, which has is present. It has is decimal. It has is in 32. It has an is within range, which we're not using. So if I go back again to my new product, all right, we've got an is present and an is decimal in there. You can see all those. All right, I'm going to try something. It may not work, but I'm going to say error message plus equal validator dot is within range txt price dot text. And what else do we have? We need name of product. Oops, try that again. Product dot price. But we need more than that. All right, what? We need a minimum and a maximum. So let's say that a book must be at least $1 and a book can't be more than $100. All right. Now it doesn't appear to like what I've done, but I think that's got to be a capital P. There. Now let's see, we added our own stuff in here. So let's see what happens if we do that now and we run this again and I click add. In fact, let's get rid of this one and we'll re-add it again. So add a new product, Java, Murach's Java 7th edition. Now I'm going to leave this as 0. And now price must be between 1 and 100. That's what we just put in. In the same way, if I change this to $100.01, which is out of range, I get the same message. But if I leave it at 100, it's fat and happy, and it puts that in there. All right. So what's neat is what we're doing here, hopefully you realize this, is we are taking common things, and how many times have we used is present, and how many times have we used is in 32 and is decimal and is within range, etc. Now we're putting them in their own class. And later on, we will take that class and put it into a class library where we'll be able to bring it into any program we want. Now it is associated with this program right here. All right. So we also have this program.cs. This is just telling us here which form we want to run first, because we've got a new product and a product main. It's telling us to start with product main. So I'm going to close that one. So let's look at product DB. All right. Well, what this says is, okay, and you don't have to worry if you don't understand this for right now, because all the stuff that's in here and that's in here and that's in here, this is all file stuff. So is this, that we're going to go over in chapter 17. Not sure exactly why Murach decided to show it like this, but they did. So I'm going to do the same thing. So this is the directory where our file will live. It's out on the C drive. There should be a C# directory, and it should be called files. Inside, there should be a file called products.txt. Let's see if we have one. So I'm going to go to my C drive. All right. And let's see if I got a folder called C#. There it is. And it says that it was actually created about a year ago, which is fine. All right. And for half a year ago, whatever. And in there, should be a folder called files. There it is. And in there should be a file called products.txt. Products.txt. There it is. And it's the only one with today's date on it. And if I look at it, we've formatted it differently for our program, but we've set it up so that it has a code followed by a description, followed by a price. And again, a code, this is the one we just put in, followed by a description, followed by a price. And SEP, or the separator that we're using, is the pipe sign. So just to show you, I'm going to leave this here. All right, I'm going to actually close it, but I'm going to reopen it again in just a moment. And I'm going to run this program again, put something in there because I don't want you to think I'm making this up. So for the code, I'm going to put in hi. For the description, this is a test of my program. And the price, I'll put in 56.78 and click save. There it is. And if I go back to my files and I open up that file again, this is a test of my program, 56.78. All right, I really don't need that one anymore. So I am going to come in here, highlight it, hit delete, and it's gone. All right, but hopefully what you're starting to see here is all of this stuff that's in here, it's working in unison. All right, we are coming in here and in our program, all right, what we have here are two different form files. The one we went over already, which is going to show us our information. The other one, which allows us to add a new product, and that's right here. We kind of looked at that one as well. It's got the things we call from validator. And notice to use that, okay, that what we need is a validator class. All right. Okay. And then we've got that product thing in there that we looked at already, or the program, I should say. This was that product DB, which is basically setting up the showing us where the file is going to live, says if the directory doesn't exist, create it. If the file doesn't exist, create it. This will be our list of products. This will basically tell us to go and kind of read through here. And every time you find a product, we want to add it to the list. And we want to do that because eventually what we're going to do in there, all right, is we're going to come in and add each one of those products to a list box. This is when we go to save the product. Again, it's going to say, hey, if we don't have it already, create a new file. Otherwise, come in here and grab everything that we had, add it to the new file, the code followed by a pipe sign, followed by the description, followed by the pipe sign, followed by the price. That's it. All right. And this product, this is our product class. This is the exact same thing that you saw, at the beginning of the chapter, the product class. So we've got a product class here. It's working in conjunction with a static product DB class here. It's also working with a static validator class here and two forms. So what we are really starting to do here is we are starting to combine the different elements together that we have been using, all right, and combine more of them together to make it more like a quote real app, unquote. All right. And again, I realize I'm spending a lot of time on this. I'm not trying to waste my time, your time, anybody's time. Rather, what I'm trying to do is to go through this slowly enough that it makes sense to you. So I think the stuff that's in here is what we just went over. Again, they show you the components of the product class, exactly what we saw at the beginning of the chapter, the components of the product DB class, which only has methods in it. It doesn't have any properties, just methods, and the validator, which has one property and several methods. Now, they do mention here at the bottom of the page, the author says here, because you don't need to know how the product DB class works, the code is not shown in this chapter, but we will talk about it in more depth than I did in chapter 17, which is on files. All right. So it says here, the code for the product maintenance app. This is kind of what we just looked at. But this has to start making some sense to you. All right. If it makes no sense or very little sense, first of all, go back and read the chapter if you haven't done so, or reread the chapter. That's one of the reasons, though, even though I'm giving you, for lack of better words, for you just doing it, kind of free points. That's why we are going to work on the chapter 12 project, which is that calculator, together. We'll do that tomorrow. And we're going to work on the chapter 12 homework, which we'll look at the end of class today, tomorrow. But I've gone over what's in here, or at least tried to. So let's look at the product maintenance form. All right, we've got this. We're creating lists, which is going to be our list of products, but we're initializing it to null when the program starts. All right. Then in main, we tell it to go out and see if we've got any existing products. And if we do, fill the list box. If there aren't any in there, there's nothing to fill, but it won't hurt anything. Filling the list box clears out what was in there and just fills it up by going through and grabbing everything that's currently in our file. All right. When we click the add button, notice what happens here. The form is modal, so we are not closing the form we had up. We are not closing that. We are creating a new instance of the new product form. And then we're saying if the product is not null, in other words, if all our checks passed. All right, so there was something in the code, there was something in the description, and there was something in the price. Then we add the product, we call the save products method of our product DB class, and we refill or refresh, as the author said, the list box. When we delete, we're coming in here. And as the author says right here, all right, we are grabbing the selected index. If we grab nothing, the selected index was -1. So there's nothing to do. But as long as it's not -1, what do we want to do? Well, we want to grab that product, but we want to say, are you sure you want to delete that? And we give it the description. And then we've got a message box in here that if we said yes, we remove it by calling the remove method of the products class, and then we resave the list box without that product in it by calling the save products method of the product DB class. Then we refill or call fill list box to refresh that and fill it up again. And that's it. Now for a new product, and I know some of this I've already gone over, that's okay. All right. So this is our new product form. Again, initializing product to null. Get new product, what's that doing? It's a this.show dialog and return product. That's going to basically bring up the new product form. Save, we want to make sure it's valid. So we are calling from the validator class. We will call the isPresent for the code, the isPresent for the description, and the isDecimal for the price. And I went back in and added a range thing, even though you didn't have to do that. All right, if everything was valid, we're creating a new product right here using the object initializer. And we're closing that form. Again, the isValid does exactly what you think it would be doing. If there were no errors, all right, it's successful. I'm sorry, if there were errors, the success is false and you show a message box. And since we set success to true here, if this fails, so in other words, if we had valid values in there, it's just going to return true. If anything was invalid, it'll return false with a message of just entry error. This then is the code for the validator class. All right. And it's the same stuff we went over already. It's the is present, the is decimal, the is in 32, and the is within range. Now, if we wanted to, needed to, whatever, we could add more methods in here, all right, for whatever it happened to be. All right, so if we were doing something more sophisticated than we are right now, where we didn't have an is method here that would meet that criteria, we could add something else to it if we wanted to do that. All right, next then is more skills for creating classes. Okay, all right. Says, in addition to the skills you've already learned in this chapter for creating classes, the topics that follow present some additional skills that you should know about. So the first is how to code properties with fields. All right. And it says the figure on the next page shows how to use private fields to store the value of properties. Now, when you look at this, we went through a few examples of doing this yesterday and about the different ways that this could be done. If you remember, we looked at instance variables, and then we used our own set and get methods. Then we used, quote, regular properties, unquote. Then we used auto-implemented properties. These are like the regular properties we used yesterday. And again, the reason that you might want to use those is if you look on here, there is more data validation or some data validation we're doing in there. So we can't use the auto implement, which just have the get set on there. All right. So they mention here a class can contain two types of fields, instance variables and static variables. Remember, instance variables mean that each time you create an object, so each instance will have its own copy of the variables, like we did for the baseball players yesterday, where each player had his own first name, last name, position, home runs, and average. All right. A static variable uses the static keyword and can be accessed without creating an instance of the class. It's like that count variable that I showed you. There's other ways that it can be used too there. I'm not saying that count is the only way that you'd ever use this, but it's a common way of using an instance variable. All right. Then next, the author says, although the fields in this figure use the private access modifier, you can declare a field as public. Then the field will be accessible from outside of the class. Public fields, as it says, are generally considered a bad practice. So you should use properties to access the private variables. All right. Remember, when you use properties with auto implemented properties, you automatically get the instance variables without you having to do anything special. They just come along for the ride, or however you would like to put it. All right. The public property should be declared with the same data type as the private field. It's also common to use the same name for the property in the field, but to use camel notation, where you start it with a capital letter. All right. Whereas for the property name, you use Pascal notation. All right. I'm trying to just show you the way that it's typically done in here. All right. So as mentioned, the main reason to code a public property that uses a private field is to process the property value in some way. So in other words, if you want to do some kind of validation on it. All right, kind of what we just talked about. So a variable that's defined at the class level within a class is called a field, typically an instance field or an instance variable. If your property simply sets and returns a value, you can use the auto-implemented properties, which we talked about and which were demonstrated yesterday. When you need to process a value before you return it, you don't use the auto-implemented properties. You code the field yourself. You've got the get and the set in there, and you can put them in and make your data validations as necessary. Again, it's common to use the same name for the property and the field, but the property name typically begins with an uppercase letter and the field name with a lowercase letter. So if you're using one of the non-implemented properties, your instance variables typically will start with a lowercase, and I've shown them, they don't even mention in here using that underscore, but that's a common practice, what I've been showing you. All right. Finally, again, if the getter or setter simply gets returns, you can use an expression bodied accessor, and they show one of these in here shows that. All right, there it is, right there. All right, how to code overloaded methods and constructors. Any method in C# can be overloaded. I want to say that again. Any method in C# can be overloaded. All right. And I'm going to check something here. Yeah. Okay. Why is that important? Well, you've seen examples. I'm going to just show you something very simple in here. Just a really, really simple example right here. Okay, so let me get rid of this. And let's suppose I'm going to make 6 different variables. Int x equal 12. Int y equals 17. Int result. All right. And then I'm also going to have, I'm going to make this smaller because I'm going to have to type a little bit in here. So instead of 48, let's make it 24. I know it's a little harder to see, but now I'm going to put in double A equal 10.41, double B equal 15.67, and double answer. Okay. Now I'm going to make 2 functions. Okay, this is going to be right here. This is going to be called, so there's some code in here. So I don't care. There's ... There's some code in here. I don't care what it is. But then lower down in my code, I'm going to put in this. Private int add 2. And we'll say int n1, int n2. And we're going to put in here return n1 plus n2. Just like that. Then underneath that, I'm going to have, and I'm going to need a little more room here. I'm going to have private double add 2, and I'm going to have in here double n1, double n2, and again, return n1 plus n2. All right. And now I'm going to change these. So this is going to say int result equal add 2 x, y. And this one is going to say double answer equal add 2 a, b. Why did I take the time to show you this? Not to waste my time, not to waste your time. But what we have here is an overloaded method. When you overload a method, you've got 2 methods with the same name, but with different signatures. technically, at least the way I was always taught, that a signature is the return type and any parameters passed in. And you'll notice that in the first case, add2 is returning an integer and it has 2 ints passed in. In the second case, add2 is returning a double and it has 2 doubles passed in. So this is going to, of course, return 29. Whereas this will return what? 15, 16.08, I'm sorry, 26.08, if I did my math right. But the point is, these methods have been overloaded. When you overload methods, all right, the signature between the methods must be different. Typically, what's going to be different is what's in here. Either the number are going to be different, or the type are going to be different, or both. All right. So I've already probably repeated some of the stuff in the book, but let's take a look at what they have. Figure 1215 presents the concept of overloading. When you overload a method, you code 2 or more methods with the same name, but with a unique combination of parameters. In other words, you code methods with unique signatures. For a method signature to be unique, it must have a different number of parameters, or at least one of the parameters must be of a different type. Not the names, but the numbers and the types. Using different names is not going to hack it. So in other words, in this example, if I'd come in here and did int n1, int n2, and in here I had int n3, int n4, that's not overloading, is what they're saying. Now they're going to use this get display text and they're going to overload that method. We're going to look at that in just a second. When you refer to an overloaded method, the number of arguments and their types will determine which of the overloaded methods gets executed. All right. Since constructors are methods, you can overload constructors as well. This is useful when you want the users of your class to have several ways to instantiate or create an object. The first example they'll show on the next page has no parameters. The second has 3 parameters. So a user of the class can create an object by calling the constructor with no parameters or calling it with 3 parameters, or by using an object initializer. So when we look right here, if you look, we've got this get display text. And in the first example, you pass in a separator. So you say what you want to have in between these. In the second case, we're defaulting it to be a comma followed by a space. They are overloaded. They're both private string, but what's in the parentheses is different. String sep, and in here, all right, there's nothing. So again, totally legal, totally legitimate to do that. What you're going to find in virtually any programming language, let's just say, for lack of better words, any kind of modern programming language, at least the ones that I work with, all allow you to do overloading. All right. Now, what we're going to get to later, not in this chapter, but in a later chapter, I believe, is not overloading, but overriding. And that means something else. But for now, if you have at least in your head, sort of an understanding of what overloaded means, you're good. All right. And when you call this, notice here in the first case, we've called get display text and we passed into there um, a \T. Since we passed something in, it's going to call that one. In the second one, we passed in nothing, so it's going to use that one. All right, and here's examples. In this first case, again, this is our regular default constructor, so it'll set everything to its default values. Here, not only have we overloaded the constructor, but we've also used an object initializer in there. All right. So, as they mention here, the name of the method combined with its parameters form the method's signature. More than one method can use the same name, but each method must have a unique signature. Methods with the same name, methods with the same name but different signatures are known as overloaded methods. And again, it's as it says, it's common to use overloaded methods to provide two or more versions of a method that work with different data types or that supply different values for omitted parameters. Okay? When you type a method name followed by a left parenthesis, you may or may not have noticed this before. And if you haven't, it's no biggie. But with a lot of these things, when you type in something, all right, what it'll show in there is kind of what you see right here. But if the method has been overloaded, it'll show you like one of two or one of three. You get some methods in .NET that literally have been overloaded sometimes 20 or 30 times. Those are going to be system things, not your things. You wouldn't overload something typically, at least that big. Be no reason to do that. All right. Since constructors are methods, you can overload them too. The signature is the name of the class combined with the parameter list. Each constructor must have a unique signature. All right, finally, they say instead of using overloaded methods, you can also use optional parameters. That was back in chapter 6. All right. Next, as it says, how to code required properties. So as the author mentions there, sometimes you want to require that a user of a class provides something or everything when they create an instance of the class. One way to do that, as mentioned, is to code the class with a constructor that accepts parameters. Then the constructor can use the values it receives to initialize the required parameters. For this to work, you must make sure that the class doesn't include an overloaded parameterless constructor. Say that again. For this to work, you need to make sure that the class does not include an overloaded parameterless constructor, one that's empty. That way, the user of the class can only use the constructor with parameters to create an instance of the class. This ensures the values that are provided are required. Then in a recent version of C# 11.0, they introduced another way to code required parameters through the use of the required keyword. All right, so let's look. So you'll notice in here, we've got public required. Since they are required, you can't just have a public class product, paren, curly brace, okay? So it says, in this example here, we've left off the price. So you can see we get an error. The price must be set. All right, and here's a way, we can use this set required members attribute in here. And, in my humble opinion, at least, this is getting pretty heavy. There's a lot of stuff. There's a lot to unpack here. That's, again, why I think it's really necessary for you to take the time to read the chapter. All right, so this is all stuff with section 11 and above. Now, usually what this means is when they give you a way of doing it like this, like where they're saying starting with C#11, someone has come up and said, well, that's a little less work or it makes more sense, etc. Okay, well, that's good. All right, but that doesn't mean that everybody is going to, like that, run off and start doing the new thing. It's just not going to happen. In addition, not just that, but in addition to that, all right, there are going to be some people, their code works and they're not going to change just because there's some newfangled way of doing it. What I'm getting to is you've got to be able to do it. You've got to be able to do it the new way, but still understand, appreciate, etc., the old way of doing it. All right? Just so you're aware of that. Okay, so let's come in here. Next, they come in, and like I said, good, bad, indifferent, it doesn't matter. They give you plenty of things to do in here. We haven't even reached records and structures and record structs, etc. We haven't even reached that stuff yet. So the next thing that's in here are property patterns, which allow you to use, as it says, some pattern matching. All right. We learned how to talk and test for some pattern matching back in chapter 5. When you work with objects, it says you can use type patterns as described to determine if an object is of a given type. In addition, you can use property patterns to match the properties of an object. All right. So as it says here, to help you see how property patterns can simplify the way you do things, you test the property values. So they've got this get discount percent method. Let's look. Here they're doing it with ifs, here they're doing it with a case, but they're doing the same thing. If O is product P, switch on O, so it's the same thing. If it's .NET, you get a 10% discount. If it's Java, you get a 20%. So you're doing it the same way. Then they even use it down here with the property pattern. Remember, this is another way. Previously, and I had shown you an example like this before. I had shown you an example where I said, just imagine that we're writing a program and A is equal to 90 to 100. A B is equal to 80 to 89. A C is equal to 70 to 79. A D is equal to 60 to 69, and an F is equal to less than 60. And I mentioned that when we did this, that I said, hey, you've got to do this. You've got to say if grade greater than or equal to 90, and grade less than or equal to 100, something like that. Then we can say letter grade equal A. Else, if grade greater than or equal to 80, letter grade equal B. Make this smaller because I'm going to run out of room. Well, we wouldn't even need this anymore. So let me make some room here. Let me doing this. All right. Else, if it's greater than or equal to 70, it's a C. Else, if it's greater than or equal to 60, it's a D. And then finally, you just have an else in here, and it's an F. Now, we talked about this. We talked about this in class. I showed you how to do this. You've done this. But one of the things we said was you really couldn't come in here and do this. I mean, who'd want to do this? Like switch on grade. I mean, no one that I know of would want to do this where they would say, and I'm not going to do all of them, but where we come in here and say case 100, case 99, case 98, case 97, case 96, case 95, case 94, case 93, case 92, case 91, case 90, and then we'd say letter grade equal A and break. Because we'd have to do that for all of the A grades, all of the B grades, all of the C grades, all of the D grades. So we go from 100 to 90, then from 89 to 80 for Bs, from 79 to 70 for Cs, from 69 to 60 for Ds, and then we could have a default case in there, which would be Fs. All right, we could do that. I mean, it's not a problem. We could do that, but it's a lot of code. Now, why am I telling you that? Because when you do come in here, and I didn't really do probably a good job at all of showing you this, but when you use those property patterns that were in chapter 5, you now can kind of write the equivalent of an if statement in your cases. All right. And that it's an important concept for me to bring up to you. So what? We're on 405 here. I want to see when this ends. I think it ends. Whoops. So we're on 405. We've got to go all the way to 418. So we've got about 15 pages. But if I go back to here, and now I'm going to go to chapter 5, how to code control structures, and somewhere in here, with these conditional, here was pattern matching on page 148. All right. And shame on me. But notice what you can do now in here. This is doing pattern matching. All right. Who cares? You should care. All right. And what I'm going to do is I'm going to come in here and let's see. I'm going to try to write this, what we have here, but I'm going to try to rewrite this using pattern matching. All right. So I'm going to say letter grade equal, and we're going to do a grade. That's the number grade. switch, put our curly and our ending curly. Let's move that down. Now we can come in here and say, all right, let's see. We could say, for example, less than uh, greater than 100. I'm going to use this one that's down here. All right, greater than 100. How about this? Less than 0 or greater than 100. We could just set the letter grade. So we could come in here and say, basically, invalid. Okay. Then we can come in here and say, greater than or equal to 90 and less than or equal to 100. All right. Then we can come in. I can line all these up. You don't have to, but I want to make it kind of pretty so you can see what's going on. Then we could say A. And then greater than or equal to 80 and less than or equal to 89, we could say that it was a B. Now, there's probably even better ways of doing it than what I'm showing you, but I'm trying to be literal here and show you everything I can think of showing you. Finally, there's that discard value, and we'd say then it's an F. All right. Now you have to come up with your own idea as far as is forgetting this one here. We're not going to use that. That would just be silly to do this. But whether this makes more sense to you or this makes more sense to you. I mean, you can see 1, 2, 3, 4, 5, 6, 7, 8, 9 lines of code. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 40, 50, 60, 70, 20 lines of code. And we could shorten that up. We could put this curly on that line, or we could actually just, you can write it like this. So we could actually write it like this. You don't even need, I'm putting a blank space in between each one. You really don't even need to do that. All right. So we could write it like that and really cut this down. Okay. But the point is, which makes more sense to you writing this stuff? Is it like this or is it like this? And the bottom line is, with what they show here, with this pattern matching, this can also be used with objects. All right. So again, C# 7.0 introduced pattern matching, which lets you test the match expression of a switch statement or switch expression for various types of tests. A constant pattern lets you test if an expression is equal to a constant value. A discard basically is like a default. A relational pattern lets you compare using relational operators. In other words, greater than or equal to, less than or equal to or not equal to. A logical pattern lets you combine, and rather than using the double ampersand for and, you use the word and lowercase. Rather than using the double pipe sign for or, you use the word or lowercase. And rather than using the exclamation point for not, you use not lowercase. All right. As they mention here, you can use a declaration pattern within an is expression of an if statement to check different things. That's what I tried showing you right there. All right. Now, I have never used one of those that I can think of, a pattern matching. In fact, that's the first one I ever did, period. All right. And I think it would work from what I showed you. But again, you can use these not just with simple things like in the example I showed you, but also with more complex type of things like when you work with objects. Okay. All right. Next. No, I don't want to use how to use the conditional operator. We were on page, what was it, 403? I don't remember. Nope. All right, that's what we just looked at, were the property patterns. So they will show you several examples in here of how these can be used. Okay. Now, to some people, some programmers, for lack of better words, are much more concerned with brevity. So they like things like this pattern matching. Other people get really confused and don't like to use that. All right. All I'm trying to mention to you is there are lots of different ways of you to be able to do the very same thing. Okay. That's what I'm trying to tell you. And you have to go through, I'm kind of giving you the tools, and some of these tools can be used for multiple, you can use multiple tools to do the same thing. All right. So you can use some of the tools to do the same thing. So what you're getting are a bunch of different tools for the same job. And you have to figure out which one makes the most sense to you. And that's the one you should be using. All right. I'm not going to go through these examples because I think you may find them confusing. That is not my goal here. There is a ton of information in this chapter that is already confusing enough. So, as it says, you can test two or more types of objects in the same switch. If you pass a specific type of object to a method, you don't need to test for that type in the switch. Prior to C#10, you had to do it a different way. All right. So the last part of this chapter, the last approximately 10 pages, we're going to go over this fairly quickly. All right. So the last 10 pages talk about how to use structures, how to use records, and how to use record structs. All right. Now, the first thing is a structure looks very much like a class, but a structure is a value type, whereas a class is a reference type. What does that mean? Remember, with a reference type, what you have, if you go to that area in memory where that class has been defined, you don't get the members of the class. Instead, you get an address of somewhere else in memory, all right, where that stuff is located. What that does by making classes reference types, if a class has got lots and lots and lots of stuff in it, 20, 30, 40, 50 or more things in it, you can pass an address as opposed to passing all those values. But when you use a structure, since it's a value type, you're actually passing the values rather than the address. So as it says, structures actually require less memory and they instantiate faster. But as it mentions right here, it's generally considered a good programming practice to only use structures when the object contains a very small amount of data and the data types are simplistic. All right. Now, I'm going to tell you something. This is not in the book. I might be totally full of it right here, but I don't think I am. All right. When I got my first programming job, I was a C programmer. All right. Actually, before C, there was a language called, I think it was like BCPL. I don't know what that stood for, but then it was shortened to B. And then they worked on that language and they made it C. All right. In some ways, not totally, but in some ways, C sharp is kind of a child of C and another language called C++. Not exactly, but kind of. The reason I'm telling you that is in C, the C programming language, which is not object oriented. I want to say that again. The C programming language is not object oriented. All right. And in C, you use structures a lot. I believe the reason that C sharp offered people the opportunity to use structures is just because of the fact that they were available in kind of precursor languages like C. All right. Now, I'm not going to go through everything in a lot of depth and breadth in here. Figure 1218 shows how to create a structure. So you'll notice when you look in here, this looks, wow, this looks pretty similar to what we did before. Yeah, but it's public struct instead of public class. All right. And you can also make something read only. All righty. It says, consider the product structure shown in the first example. It includes 3 read-write properties and the get display text. In other words, everything that we found in the class, basically, all right, is now in here. Okay. But because the structure doesn't contain a parameterless constructor, unlike a class, C sharp will generate a default constructor, even if you've already got overloaded constructors. You always have it. With C sharp 10 and later, you can still create your own parameterless constructor if you want to, or you're going to change it around a little bit. Another difference, as they mentioned there, between structures and classes is prior to C sharp 11. If a structure contained a constructor that accepted parameters, the constructor had to initialize all of the properties. Now that's no longer the case. Also prior to C sharp 11. If a structure used properties with fields, the constructor had to refer directly to these fields, not to the associated properties. With C sharp 11 and later, this doesn't apply. In some cases, you won't want the values of a structure to be changed as the program executes, so you can create a read-only structure. And I don't think I have to go over this on the bottom because it's what we just mentioned. So the next figure shows you how to use a structure. And I think what you're going to see in here is it's going to look a lot like what we just did with classes. All right. It looks very similar. You instantiate, you've got the name of the object dot the name of the property. So it doesn't really look very different. So again, the advantage of using these, is the fact that they will instantiate faster, they will use less memory. The disadvantage is that they're really only recommended for very simplistic types of things. All right. I think that's, hopefully at least, that's enough on this. Now, Records, as it says, work like structures. However, records are reference types. All right. A record can have all the same members as a class or a structure, like classes, but unlike structures, records support inheritance. You don't know what that is yet because we haven't gone through chapter 14. And they don't generate a default constructor. Although records are reference types, some of the stuff they do, like equality comparisons, work the way they do with structures. So if we look in here, here's a record. So we had first public class product, then we had public structure product. Now we've got public record product. You see again in here. All right, we have a constructor. We've got properties. Again, it looks very similar. So as they mentioned here, a record is a reference type like a class, but the record's equals property and equality compare the values of its properties. A record can contain the same type of members as a class, and you can't inherit. All right, I'm just going to stop it right there. Okay. All right. You may have heard this saying that, what is it? When the only tool you have is a hammer, the world is a nail type of an idea. Okay. Well, the problem is you're getting a bunch of tools. You're getting a class tool. You're getting a structure tool. You're getting a record tool. And now you will be getting a record struct tool. All right. So no, it's not the world is a nail, but if you're trying to solve the same problem, and it's a fairly simplistic problem, you can use any of these. I'm going to, this is me speaking, and I'm going to say that I would recommend that you load up and be heavier on classes, and for now, at least where you are in your career, not worry about records or structures or record structs. Now, as they mention here, a record struct also works like a structure, and like a structure, it defines a value type. However, it provides better equality comparisons than structures. All right. So again, there are examples in here as well. Then they update the product maintenance app to use a record. It's going to look similar to what we did before, but again, we're using records. Other than that, I'm not going to say it's identical, but it's going to look very similar. So as it says, this version of the product maintenance app uses a record rather than a class. This code uses the constructor-like syntax to create a read-only record, but it adds an overloaded getDisplayText method within braces. Since a record compares the values in an object's properties, it's easy to add functionality to an add button, all right, to check to see if a product is already in a list. And that's it. Now, we don't normally do this, but let's take a second here and actually look at the perspective part that's here. All right. And as it says, at this point, you might wonder why you should go to all the extra effort of dividing an app into classes. The answer, as they mention here, is twofold. First, dividing the code into classes makes it easier for code reuse, so you can use the same stuff in multiple applications. You saw a very good example of that when we started talking about the validator class. Now, rather than adding those things every time, and some of this, like I said, you won't understand libraries until chapter 16. but you'll be able to make a library. I mean, think about a library. What is it? I know libraries do a lot of stuff today, but when libraries were created, they were basically set up for you to be able to take out books. So on an as-needed basis, you could go in and get a book, right? I don't care about that, that might be checked out. It doesn't matter. But in a class library, it's the same thing. You kind of go in, for lack of better words, check out a class that you can use in your application. Second, as it says there, using classes helps you separate the business logic and database processing. Now, since we haven't talked about databases yet, that might mean very little to you. That's okay. All right. Okay. So not today. All right. But the next chapter we're going to go through is not a real long chapter, and it's going to be on indexers, delegates, events, and operators. All right, we will do that when we get back from the break. Actually, about 2 weeks, I would guess 2 weeks from this Thursday. We're going to go over that, and we're going to go over chapter 14. All right, this is a very, very important chapter because it will introduce inheritance to us. We will build an application, and that application will use the basic skills of inheritance, and it will use abstract classes and maybe even a sealed class. I don't know. Then the following week after that, we'll go over chapter 15, which is again fairly short, on interfaces and generics. We'll talk mainly about interfaces, a little bit about generics, and then finally, we'll get to the point where we will, again, not a long chapter, but we will learn how to organize classes and how to actually create a class library. And I think that'll hopefully tie all of this stuff together. All right. Okay. Now, I've mentioned this before. I'm saying it again right now. Tomorrow, we are going to do project 3.1 together as a class. All right. I am literally going to take, yesterday I gave you an email, and that email, I don't know if I still have it out here or not. That is not it. This is the email I gave you yesterday. All right. And I told you we're going to create this calculator that's right here, that one together. And I told you the form should be this size if you want it to look like the one I'm going to create. The label that is right here should be this size. The back button and back button and clear buttons should be this size and this size. These buttons that are in here, every button in here except for the equals should be this size, and the equals button should be this size. All right. So I am going to go in, not in front of your eyes right now, but by tomorrow, I am going to build that. Please make sure when you build it, you use these names. So the number 1 will have BTN1, the number 0 will have BTN0. So this will be BTN0, BTN1, BTN2, 3, 4, 5, 6, 7, 8, and 9. All right. We'll have a BTN add, a BTN subtract, a BTN multiply, a BTN divide, etc., a BTN square root, all this stuff. I'm going to just use everything. The only thing I think I'm going to do that's going to be different is, instead of it being called FR calculator, since we've been using FRM, I'm going to call mine FRM calculator. And I think I'm going to try to use everything else that they have in here. All right. Now, for you to understand what the heck we're going to be doing tomorrow, when I start, I'm going to start with this problem. I'm going to have this interface built already. I am not saving what I'm doing for you. It will not be out on a GitHub repo. It is still homework. You still have to do it. All right. But after so I'm going to start with that interface already built. Okay, so we'll have this already. Then I'm going to go through all of the different operations. So in other words, I'm going to go over all of the requirements. All right, and it's not going to take a long time because what they're saying here is if I want to add 6 and 10, I'll put in 6. I'll hit plus. I'll put in 10 and I'll hit an equals. That's it. If I want to be able to add to that, I'll be able to add on to that as well. And then how to do a square root, etc., all the other stuff. How to erase the last character entered. That'll be the back. How to clear out everything. That'll be the clear, etc. So as it says here, we will create a class named calculator that will implement the functions of the calculator. Plus, if the user attempts to divide by 0, the calculator should display an error message inside of the box here. And I'm still not sure if that's a label or a text box. It won't matter. We'll look at it tomorrow. All right, we should use a try catch for this and check for a divide by 0 exception so the program doesn't blow up. And then there's these instructor notes. So we're going to go over all of this tomorrow. All right. Says if you want to be more specific about the calculator class, you can provide this class design. And I'll have to go back and look at my code, but I think that's the way that I did it. I did this a couple years ago. All right, so I have to go back and review it myself. And these things that are in here as well. It's a lot of work. It'll take some time to do this. All right, and I'm going to go tomorrow, as I mentioned, only from 8 a.m. until 11 a.m. because I have an appointment that I'd forgotten about. That's tomorrow, and I tried rescheduling it, and I can't. All right, so we'll only go tomorrow during that time. All right, now my appointment should take 2 hours from 11, well, maybe 2.5, from about 11 till 1:30. All right, so if I am working on the first one and get it done, and then I start the second one, which is this one right here, I could go back for an hour and work on it. We'll see. All right. This is the other exercise. So as it says, we're going to add a class to an inventory maintenance application. You're given a lot of this stuff already, but it's very similar to what we just did. If you click add, it brings up this modal dialog. All right. If you click delete, it brings up this one. So it's very similar. All right. So a lot of this will be in here. It says review the existing code, but we can use the one that is used with our product maintenance app that we have as an example. All right. Then we'll add a new class named INV item with these properties. We'll add the code to implement the new item form. We'll add the code to implement the inventory maintenance form. All right. If I do not finish this tomorrow in 3 hours, all right, if I have to, like I said, I will do another video in the afternoon tomorrow. We'll see where we are at that time. But the plan is to have this done by tomorrow. Then on Thursday, to give you the the pretest. Again, please remember that next week, there is no class on Monday, July 3rd. There is no class on Tuesday, July 4th. You're off both days for the July 4th holiday. All right. So what I'm going to do right now is I've made a picture. Not that, don't need that. But I've made a picture of this. All right. I'm going to stay online and I'm going to build this thing from scratch. All right. So I'm going to literally just create this. Then I'm going to go back and using the requirements that I gave you in here, I'm going to change it and put in all that. So I'm going to have, when I get done, I'm going to have this interface built. I am not saving it for you. I am expecting you are all smart enough that you can all make this interface yourselves. All right. So I'm going to do that. I'm going to stay online and start doing this right now. So I now have calculator project is the name of the project. Calculator solution is the name of my solution. And calculator is the folder in which this is all kept. Okay, so I'm going to click create here. And there it is. All right, so with all that done, let me go back and just start working on this. All right, so this is the size of my form. So I'm going to change the name of the form right away, rename it as FRM calculator. Yes, I want to make a permanent change. What did it say on here? This should just say calculator. So that's the text. And the size should be 545 by 520. So there that is. All right. And then again, I'm looking on here from what I saved, and this must be a label. All right. It makes sense for it to be a label because you can't put your own stuff in there. So that makes sense. All right. So I'm going to make a label. We come in and make that label. That is going to be white. So the background color on that will be white. All right. And I'm going to come in and set the auto size to false. And I'm going to make the size of that label is going to be 434 by 46. All right, so that's here. And it doesn't look bad where it's positioned. I am going to make this nice and big in that I want to come in here and change the size of what comes up in here. I hope that doesn't make this thicker. Didn't. Good. So there's my label. All right. Let's see. I don't need any text in there, so I'll get rid of that text. All right. And it is called LBL answer, which is fine. All right. Next, I'm going to come in and create two buttons. They will be my back and clear buttons. So there's one, and there is the other. Okay. So this will be the back button. I think it'll probably be called BTN back. Is that right? BTN back and BTN clear. All right. So this will be BTN back. And it'll have the word back on it. This will be BTN. Oh, and also the text is in red. Why? Because they did it that way. So the foreground color will be red. All right. And this will be BTN clear. It will have on it the word clear. And again, the text will be red for the foreground color. All right. So the size of the back button should be 191.70 and the other one is 228.70. So this will be 191.70. And that is wrong, what I just did. Changed the location and I meant to change the size. So there's one. Bigger than I thought it would be. But that's 191.70. And this one should be 228.70. So there's the other one. Move that over a bit, and we'll move that over a bit. Okay, so there those are. Let's change the size of the text in our button. Again, like we've been doing, we'll make it 24 bold. Arial, boom. Okay, those two are done. All right. And then we need, what else is left in here? We got that done. We've got that done. We've got that done. We've got that done. We need 18 buttons that are 75 by 54. Let's just make one button. Move it down here. Let's change the size on it to 75 by 54. All right, so it's that size. I'm going to move this up. So it's almost at the top. I'm going to bump that up real close to it there and there. All right. So let's see. As we're making this here, this will be 1, 2, 3, 4, 4, 4, 4. 4 rows of 4. I want it to look somewhat like it does in the book. It doesn't have to be perfect. All right, but it should look something like it. So I think this can all come down. It's a little better. Okay. All right, looks like these are going to have to be much closer together than they are. And they must be. All right, this is coming together. Okay, so I've got all those in what's left. So these are all done. I need two more, and then I need one over here, the square root and the 1x. Square root. There will be the 1x. And then we'll need one bigger button here. So, and the size of this bigger one will be 75/130. Okay. This one will be 75/130. There's my interface. Okay. Now, as I'm quirky, that doesn't look bad. It's not perfect, but it doesn't look too bad. In fact, one thing I want to do here is I want to grab all the buttons, pull them down just a little bit more. Grab these two buttons, move those down a little bit more. I want this to be closer. There. That's about, I think, as good as I could make it. I'm not saying it's perfect because it sure as heck is not. Okay. All right. So let me go in and let me lock the interface. All right. This has already been named. So the form is FRM calculator, LBL answer, BTN back, BTN clear. So going down then, oops, these will be 7410. So this will have a 7 on it. And it will be BTN 7. I'll change the size of that just a second. 4. Seven, 4, 1, 0. 1. And 0. Now, I don't know if 24 is going to be too big for these numbers or not. We'll find out right now. That looks pretty nice to me. So 7410. And these are all blue. So the foreground color, instead of being black, is going to end up being this blue here. Okay, so those are done. All right. Let's see. In the second row then, let's just change a couple things right away here. So I'm just going to do them the way I'm going to do them here. So this is going to be a foreground color of that blue. And it's going to be, this may be too big right now, but the text will change in just a moment. Like I said, that's why you just see but there instead of button and the number. We'll change that right away. But looks kind of silly there anyway. So the next ones are 852 plus slash minus. So this is 8. So that will be BTN 8. And it'll be the number 8. This one will be 5. And it'll be called BTN 5. This will be called 2. BTN 2, not 27. And it'll have the number 2 in it. Okay. And this one, I don't remember what it was called, so let me look. Plus minus. Oh, let's call it what it really is. Okay, so this will be BTN plus minus. And it'll have on there a plus sign, a slash, and a minus sign. That's done. Let's go to here. And again, we will change the size on here. And we will make this 24 bold and Arial. And it'll just say but. We will change the foreground color to that blue. Okay, those are done. And we'll come up to this one. And what do these say? So we've got 963 decimal point, which are 963 and decimal point. Okay. So this one will be BTN 9. And it'll have a 9 on it. This, I believe, is, what do we say, 6.3 in decimal point? Yep. This will be BTN 6. And it'll have a 6 on it. This one will be 3. And it will be BTN 3. And this last one will be BTN decimal point. And it will have a decimal point on it. All right, we're getting there. The next ones. All right, these next 4 then will be divide, which will be, I think it's just BTN. Divide, multiply, subtract, and add. Divide, multiply, subtract, and add. All of them are red. as their operations, I guess. So we don't want the background color to be there. We want it to be here. Okay, and let's change the names. So this first one will be BTN add. The second one, I'm sorry, this will be BTN divide. The next one will be BTN multiply. The next one will be BTN subtract. And the last one will be BTN add. All right, and then doing the last row. I think these are blue again, but let's check. Blue, blue, and red. That's fine. So these two are blue. This one is red. All right. And we have here square root 1x, which is the reciprocal, and equal. So this is square root. This is the reciprocal. So it's 1 over x, I believe is the way they show that, right? 1, yep. So this will be BTN reciprocal. And this last one will be equals. All right, let's look at that and compare that with the way this looks. So I'm going to do this, bring this over. I guess my blues are a little bit different. I need see if I can grab a different color blue, maybe. Everything else, as far as I can tell, well, the square root didn't fit in there, so I guess the text is a little bit too big. I'll make the text smaller. That's no biggie. Okay. And I'll try to get a different, like a more darker blue. All right. But everything else should be done. So let's do all that right now. Cancel that, get rid of that. Now let me highlight all of these. Try a navy. No, I don't like that. It's pretty close though, I think. There was a dark blue in there too. That looks good to me. All right. The other thing I'm going to do is I'm going to highlight all of these. I should be able to change all this at once in the font, I would think. It's not letting me. Why not? All right, then let me try these. Let me see if I can do these. Yep. And I'm going to change the font down to 22. A little smaller and do the same thing here. Oh, it doesn't like that, so. Fine. That already is 22, I guess. So these two, see if I make those 22, if that'll go down enough where you can see the T in the word square root. There. And I'll make this one 22 as well. In fact, let's leave this one at 24 and this at 24. All right. I kind of like the way this looks right now. Now let's do what we always do. All right. So I'm going to click on here and I'm going to set my accept button. I'll set it to BTN equals. All right. I don't even know if you're told to do this, but I'm doing it anyway. My cancel button, notice it's got the outline around it now. My cancel button, we'll make it BTN clear. That's fine. All right, so that's done. There's not exactly a tab order in here. I can set my start position to center screen. But I mean, if I want to, I can set this. But what, I mean, what should I do? I don't even know. I'm not going to set a tab order. All right. Yeah, well, I will anyway. That's fine. So view tab order. It's probably going to look a little weird, but I'll make it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I don't know. That may make no sense whatsoever as a tab order, but it still is okay. So file, save all. The only other thing I want to do is I believe with buttons, they have a style. I can't remember what, it's not called style, unfortunately. But there's like a sunken in effect that you can get with buttons. I'm going to see if I can find that. Auto size, auto ellipsis, auto drop, accessible rule. Text align, text image relation. Flat style. We made it flat. Don't know if that's the one I want. Pop-up? No. Standard? I think that's what it was. And system? I don't like that either. See, these are all standard. I thought there was a way to make a button look kind of more sunken in or like 3D type of effect. It's not terrible. So let's do a file save all here. All right. And let's run it. And there it is. It doesn't look bad. Okay. Okay. So that'll be my calculator. Now, next, what I want to come in here and do, because it'll just save me some time for tomorrow, and that is to come in here and let's see, oops, the wrong one. All right. This will be my prologue. So I'm going to put that up at the top. Don't think I'm going to need most of this, so I'm going to get rid of that. All right. Need that prerequisites, chapters 1 to 12. Okay. Okay, that's good. All right. And let's see, what else do we have here? So we've got that. This will be the operation, and those will be our specifications, our instructors. That'll be the calculator class. Again, after we get done with chapter 14, we'll look at putting in a memory capability. All right. Design. So let me grab this operation here and the specifications. Copy that. All right. Clean this up a little bit. Form. Second number. Okay. Okay. Wait. I should have a little dot there, but that'll be fine. That's everything. All right. As far as what it showed at the beginning. Now I'm going to do one more thing, and that is I'm going to come in here and I'm going to create a new class. So I'm going to add a class. I'm going to call it calculator.cs. I'm going to immediately come in and change that to public. I don't think I'll need any of these, but if I do, the system will tell me. So I'm going to get rid of those. And I'm going to come in and just like I did previously, All right, I'm going to put in, I'm going to put in those specifications. All right, and that's going to be all of the stuff that was shown here. I don't need the instructor notes. I don't think I need this. Because they talk about enhancements and stuff. I'm not going to worry about that. But I'm going to grab every bit of this. All right, and that'll be the first page. And then there'll be a second page there. Okay, so we'll put both those in there. There's the first one. I said this will take a lot of fidgeting around, and I'll do that in just a bit. And then this is the next page. Right there. So let's see if I can pretty this up a tad. Private field description. It's like that. That looks about right. So these are the private fields and the descriptions. These will be the properties and the descriptions. And move that down and let me add this. I'm quirky about a lot of the stuff here that I do. I get it, but hey. Yeah, I like the way this looks. This is all over the place, but I can fix that if I want to later. All right, so method and description. Oops. That. This over. Okay. I think what I am going to do is I'm going to take this because I'm prettying it up quite a bit, and I'm going to give you this. So if you want to use these comments, you can. If you don't want to, just ignore the fact that I sent them to you, I guess. So let's see. Pretty this up a little bit. Okay. All right. That's about as pretty as I can make it. Now I'm down here because I don't remember. So I've got add here. I want to see what it says in the book. I'm up to here. So there's add, subtract, multiply, divide. Okay, good. All right, so that's prettied everything up. I'll give you this. So this has got all of the documentation, the internal documentation. So this is it for the calculator. I'll make sure I send this to you. And this is for the form itself. All right. So again, when we start tomorrow, I'm jumping right in. All right. And I'll read these and I'll go back and look at it because I have done this before. All right. So I'll go back and I will read all of the requirements. I'd like you to do the same, please. And we're going to jump right in and do it. If we do get it done, ideally we'll get that done in about 2 hours. Okay. And we may have a very abbreviated break schedule tomorrow. Okay. Then we're going to jump into this one. And I'm going to read this one as well. Create and use a class. So I will have all that information available for you tomorrow. All right. I'm going to look and see if I've already created a pretest for chapter 12. And if I have, you may even get that tomorrow. So if you want to start working on that, you can. All right. And otherwise, I'm going to have to write it, and I probably won't be able to write it until tomorrow. Okay. Anybody who stuck around for all this, I very much appreciate it. I have not taken any breaks, so it has literally been about 3 hours and 35 minutes. All right. So with that said, I will talk to you tomorrow. I hope you have a good day. See you later.